Hello, everyone. My name is Rodrigo. I am the Corporate Services Manager at Zigurat, and welcome to the CONSTRUWEEK. Thank you for joining us, and hope you enjoyed this great event. So, Zigurat is the most advanced and prestigious e-learning training institute worldwide. 2022, it's a very special year for us. A few months ago, Zigurat celebrated its 20th anniversary, 20 years leading the e-learning industry, reaffirming its leading position as an educational institute in the fields of architecture, construction, and engineering. Since then, our mission is and has always been to speed up and transform organizations and people careers, help them meet the most challenging market demands, and guide them to be leaders in the industry. So the second edition of the CONSTRUWEEK is the reason why we are here today. The CONSTRUWEEK is an online, global, and 3-day event dedicated to the new era of construction industry. Its goal is to present the most innovative strategies and solutions applied to the phase of design, construction, and maintenance. We will dedicate one day for each stage, and today is the design day. Each day, important companies and renowned experts in the sector will join us to discuss the most innovative business strategies and latest solutions to speed up projects while improving their safety and reducing their costs. Today, we will have 2 presentations, and at the end, we will invite a special guest from our faculty to lead the roundtable discussion. For all the audience who are here with us today, thank you to be here. I encourage you to leave your question on the chat, so at the end, the expert can reply to you. It's a pleasure to introduce you to our first speaker. Great. Go ahead.
Hello, everybody. Good afternoon. The voice is clear?
Yeah, we can hear you clearly, Mohammed.
Okay. Hello, everybody. Good afternoon. This is Mohammed Fauzi. I am the VIM manager for Shakir Consultancy Group. It's my pleasure to be with you in this event, which is hosted by one of the most valuable education institute like Zigurat. And I hope this event will be interesting and hope it can add value for you. I'm going to share with you at this event some of the applied them in real lifetime project which we used in our company, especially at Egypt. We realized in Shakir Consultancy Group that BIM is not an option anymore. Due to the market competition and due to the quick change that happened in the market, we realize that we have to be ready and we have to use them, whatever you are a consultant or a contractor or even a developer. Them has been not an option, it's a mandatory for all the construction parties. So we found that the innovation in the projects, the changes in the design and how it looks more fantastic, this requires more difficulties in some of the design stages. We found that some requirements from the owner right now that they need the projects to be done and done. And even from the government itself, they requested in order to make approval for the project and in order to give a release for some of the projects, it has to be done in them also. Finally, due to the market competition and as Shakir Consultancy Group need for always to be at the first line of the construction companies in the field of the construction, so we decided to move on to this new technology, and we decided to implement them into the company and to use it inside our products. My first case study that I'm going to share with you is for Alamein Downtown Towers, which is done still under construction, but it exists at Egypt, and the MEP designer is Shaker. This project consists of 5 towers. Four towers are 56 floors, and they are about 250 meters tall. And one tower is an iconic tower with about 68 floors, and it's about 300 meters tall, which will be considered the tallest skyscraper in Africa when it's finished. Okay, so we realized and found that due to some competitions and some complications, in this project, we have to use them for this project. First, as it's a skyscraper, so the design and the construction of this project is more difficult than any ordinary project, any ordinary building. Okay, and especially for the structure design. Structure design has become a very difficult obstacle in the project because we cannot make a request for penetration for the beam or to reduce the width of the height of the beam for an MEP penetration. I'm going to talk as an MEP consultant because this is our role in this project. So the structure and the design stability of this building was the most important thing in this project. So we have to customize and we have to go on with this structure design because it's according to loads and calculation, and we have to manage our electromechanical systems. So what was the solution? The solution was to use BIM technology for this project by BIM software like Revit and Navisworks. We made our design in BIM, in Revit, and we make the check into Navisworks for all towers, whatever it is, 4 small towers, it will not consider it small, but or for the residential, for the iconic tower itself. This helps us to make an early highlight for some issues that may come out due to design mistakes or due to some coordination issues that need to take care before construction from the design stage, from the beginning. Second piece of art that I wanted to share with you is another project which is called the Cairo Monorail. Cairo Monorail, it consists of 2 lines. The first line starts from Masr city and it's going through New Cairo capital. It's about 54 kilometers long. It's including about 16 stations. And the second line, it goes from Giza city to 6 October city and about 42 kilometers long, and it consists of 22 stations and 1 depot building. We managed to use them in all the stages of the design, from the concept to the preliminary and going through the detailed design by using all the available BIM software like Revit and Navisworks, and for sure also AutoCAD had a part in the process for this project. So there was an architecture Revit model and there was a structure Revit model, and our part was to create the MVP Revit model. In this project, the architecture and the structure designer was a designer from Spain. It's called Semir. So for sure, we have to make more clashes, more check, so more clash test and check into our models. So we use also Navisworks for the quality assurance and the quality control for our model. Visual inspection is very important and it's very effective in analysis work, not only to make a clash detection and get some clashes and try to solve it. So we use again the Revit for the design and the analysis work for the quality control and the quality assurance. As I mentioned, that the architecture and structure designer was Samir from Spain. So we have to use also one of the solutions, the cloud solution, which is the BIM 360, in order to manage the data, in order to manage the revisions of the model, and to get benefit of all the features that exist in the cloud solution. So this was very important, especially in this project, because a consultant, some consultant exist in a country and the other exist in another country. Finally, I just want to let you know that then now it's not an option, it's mandatory. So all the companies, whatever it's consultant, contractor, or developer, have to manage to use Revit through their company. For sure, implementing Revit may take some time, may have some difficulties, but at the end, we have to use it because the benefits from using them, not only in the mega project, even in the medium or small projects, is more than using the traditional way that we are using in our old projects. Okay. I will be here to join you to the next session, which is a roundtable with Engineer Nanya. Thanks for you, and I hope my presentation was interesting for you. Thank you.
Thank you very much, Mohammed. Really interesting, the project that you just presented to us. And it's amazing how BIM is helping the industry to be more efficient, to reduce costs. And your presentation was really, really beautiful. And actually, I have to tell to the audience, like 3 weeks ago, I was in Egypt, and Egypt is really an industry that is booming, no, for all these new mega projects that are constructing. So thank you very much, Mohammed, to bring this topic to our attention.
Thank
Okay,
you.
and stay with us because we have some questions for you. Okay,
Sure.
so
Okay.
our second speaker today is Luai Kurdi. Hi, Luai. Thank you for your willingness to take part in the CONSTRUWEEK. We are very pleased to have you. So Luai is going to talk about 3D concrete printing in construction and talk about different success cases. So Luai, welcome. The stage is yours.
Hi, Rodrigo, and hello to all of the audience. Thanks, Zigurat, for inviting me to this event, and I'm happy to be joining you. I'll jump right away to share my screen, and we can start with the presentation. Rodrigo, just could you please confirm if you can see my presentation? Rodrigo, are you there?
Yeah, I'm here. Yeah, we can hear you and we can see your presentation. Yeah, it's
all
very
right.
clear.
Perfect. All right. So today I'll be talking about 3D concrete printing in construction. My name is Luai Kurdi. I'm the founder and CEO at Print4D. We're a 3D concrete printing company. We develop the technology and provide the printers to clients all around the world, where we are working with robotics for construction projects, large-scale 3D concrete printing. So my presentation is going to be mainly about a few case studies where I've worked using this technology, and also some information about 3D concrete printing and different technologies currently being used around the world. So with the first case study, I'm going to jump right into the first 3D concrete printed facade in the world. It's located in Dubai, and we managed to print 880 facade panels for these 2 office buildings in Dubai. And for each building, it took us around 3 weeks to complete the printing of the 440 unique panels. So this is how it looks like when we are printing the panels. Each panel is around 4 centimeter thick. And after we print the panels and they are ready, we basically install them onto the building as a cladding. So these panels are mechanically fixed with stainless steel anchors. And all of these projects I've did while I was working with B6 back in Dubai. So this is how we are able to print in a very short amount of time, 3 weeks for each building, unique panels, different dimensions, different heights and different widths in a very efficient manner, all using a digital workflow. So we don't really have to have any shop drawings or fabrication drawings printed physically. Everything goes straight from the 3D model into the printer and to the code. And this is the second office building where you can see another angle. Jumping right into the second case study. So this is the first fully structural load-bearing building in the UAE, where we did not have to use any steel reinforcement for the walls of the building. So this was a 70 square meter building printed in Abu Dhabi on a golf course. And basically the function is that it's a kiosk or a shop on the golf course to serve drinks and food for the golfers. So immediately you can see we were able to print the full building from the exterior walls all the way to the interior of the building. And this was the strategy that we used was a prefabricated offsite manufacturing. So basically we printed 78 unique panels or wall modules in Dubai in the factory, and we shipped them to Abu Dhabi around 1.5 hours in the truck, where we laid them down next to the site and basically started installing piece by piece. So we complete the whole building. So the technology highlights that were used. With 3D concrete printing, we're able to have a big freedom in design and introduce a new architectural language. So we are breaking free from vertical surfaces, flat surfaces that we are very used to in the construction industry, where it's very typical to use wooden molds and cast the concrete inside. But with 3D concrete printing, we were able to create very complex double curved surfaces, as you can see in these two walls that I designed, and kind of introduce a new way where we combine organic geometry, inspiration from nature, and really create some interesting architecture. So the technology that we're currently using is a fully digital one and also fully automated. So it means we design on the 3D model, on the 3D software, and we're able to send the model sliced already and the printing code to the printer itself, and it can run in fully automated mode. So there is no human intervention during the printing, and our role basically is more a supervisory role where we just check the material, make sure that the printing is going well, and do minor tweaks here and there. So we definitely work with BIM models before we start printing the project to make sure that all of the different disciplines of engineering for the project is well coordinated and we don't have any problems after we start printing the first wall. So after we print all of the modules, we ship the items to the location, and you can see here the video on the right side, which shows you the segmentation logic, where we print the exterior walls separately, the interior walls separately, and then assemble them together. So this gives us the ability to have operations running in parallel, both in the factory printing and on-site, for example, in preparation of the slab foundation where the walls will all be assembled. And here you can see on the right photo, although that we're following a additive manufacturing approach, which means we're printing layer by layer, but all of our layers are monolithic in a solid structure during this process. And this is how the assembled building looked like. You can see all of the printed layers even on the final finish. And going into the architecture and features and the solution of this technology. So here, as I mentioned before, we didn't use any steel reinforcement. It means that all of the printed walls are load-bearing elements. And you can see the different architectural features. So we don't have any vertical surfaces. All of the facade surfaces are inclined in different angles. And this is one of the features that the technology gives us the opportunity to do. And in addition, here you can see the fully coordinated BIM model that we have prepared before we start printing, where we understand how the utilities and services are well fitted within the printed walls, and we can make sure that we are having a clash-free project. So this gives us a new way of building. Basically, we are introducing a complete building block from the most exterior part of the building, where it can become an artistic facade instead of just a cladding element, all the way to the interior of the building, as you can see in the right photo. So here you can see the exterior facade. We have an insulation cavity behind it where we're able to put insulation, for example, and then we have a structural infill, and then you have the interior wall. All of this can be printed at once, definitely modeled and engineered using the software. And once we start printing, this element took around 2 hours to print, and overnight it cures, and we were able to transfer it into the storage location. So this accelerates the building process because you don't need to do the cladding separately. You don't need to make a formwork for the installation. You have a full building block ready for installation on the project site. Other types of challenges that we faced during this project specifically, for example, was the lintel element. So typically you would have the lintel element sitting on columns supported on both sides, as you can see on the left-hand side. This is Project Milestone. It's also a 3D concrete printed project in the Netherlands, and you can see that the lintel is clearly sitting on supports from both sides. We wanted to innovate a little bit on that, and instead of having the lintel sit on supporting columns on both sides, we decided to have it suspended from the roof, as you can see on the right side, the section. And basically what this allowed us to do is to keep the joints continuous and clean in a vertical way without having additional horizontal joints in the project. So these are small details that we wanted to push in the projects, and definitely it's very exciting to innovate on such small details even in 3D printed projects. As I mentioned before, all of the exterior walls, you can see the different inclination angles, so we don't have any vertical walls. And this is basically what we try to do in this project, is utilize the technology to the fullest capacity. Going into a little bit of the speed of the construction. So this project took us 3 weeks to print and around 4 weeks to assemble and finish. We did not have to do any additional finishing or plastering, both on the exterior or the interior walls. We had the work on site and the off-site in parallel, and we only needed a small team on site, basically to lift the elements and install them on top of each other and next to each other. And then additionally, finally, we only have a small footprint on site and minimal equipment, which basically means that you don't have to have a big team on the site to get your construction project finished. Now I'll jump a little bit talking about the different technologies currently being used in the market, where we are using the robotic arm for printing, and there is also a gantry printer. So on the right-hand side, this is our printing facility in Czech Republic, where we're using a robotic arm to print. And on the left-hand side, you can see the Cobot gantry printer installed on site and being printing projects on site. To compare both technologies, for the robotic arm 3D printer, it's fixed in a location in a factory, printing factory, and we don't have any downtime because we basically are printing in a fixed location, and the printer is not moving, and it doesn't need to be installed and set up every time. However, that cannot be said the same thing about the gantry printer, where the printer needs to be transported, installed, assembled, calibrated, disassembled after the project is finished, and the whole cycle over and over. So you have a little bit of downtime. Also, we are printing indoors inside the factory, so we can make sure that we have full control over the printing conditions, the environment, and have very high quality control standards. But the problem is printing on site, you rarely have full control over all of the aspects, especially the environment, and especially in cold conditions and rainy conditions, where it can become a little bit challenging. So printing on site is a very exciting and a great achievement, but unfortunately, sometimes when it comes to hot climates or cold climates, it proves to be a bit challenging. In addition, there's some differences in terms of the quality and the print resolution that you're able to produce. With the robotic arm, you're able to produce with a print accuracy of plus or minus 0.05 millimeter, and you can really create intricate and fine details. Whereas with the gantry, because the weight of the nozzle is heavy and all the overall system is quite big, it's very difficult to create fine details and produce very good finishing. And most of the cases, these walls have to be finished with plastering to hide the imperfections. So how do we compare 3D concrete printing with traditional manufacturing or traditional concrete construction? Today, the material is proprietary for 3D printing, which means it's been specifically developed for this technology, and that makes it a bit more expensive. So today, the market range is between 6 to 8 times more expensive than normal concrete. But at the same time, there are some exciting developments taking place where some companies are using normal concrete, which comes to a very similar price as traditional mixes. In terms of speed and time, with old and traditional methods, it's quite time consuming. You're having to build one block at a time. You need a large construction team, and there is room for human error, of course. But with our robotic technology printing concrete, we are typically 6 times faster than traditional concrete manufacturing. We have a continuous printing technology. On average, we're printing 15 centimeter per second, and we have very short lead times from the time that we produce the design on our software and initiate the printing process. And we also don't produce any errors, and we only need a single printer, not a full team. When it comes to sustainability and green aspects of the technology, because we are able to optimize our walls, as you can see on the left-hand photo, we're optimizing our walls, so it means that we don't need to have the wall full of concrete, but we only print the concrete where it's needed. We're able to save around 55% of the concrete in the wall elements. As well, from a concrete material mix, we're able to use lower cement content, which in terms reduces the CO2 footprint. And we are testing with recycled and waste materials for the concrete mix. And we're producing 50% less CO2 emissions. And this is only, a small number that will grow higher, and we're going to be able to produce less CO2 emissions as time goes by. Sometimes it's a bit difficult to compare the traditional approach with the 3D concrete printing approach. And I call it the direct comparison problem. With the traditional approach, you have repetitive labor expenses. So you have to hire your labor every single time you want to produce a project. You have a lot of construction mistakes. So sometimes some small detail needs to be repeated twice or even 3 times. And your construction team needs supervision. But with the 3D concrete printing technology, it's a one-time investment. The components, the hardware, can last for tens of years and with very low maintenance, and it's an autonomous process. And we really start to take advantage of this technology when we start to move away from boxy designs and to create some new kind of architecture that will fully benefit of the technology because traditional construction methods will not be able to produce it as competitive enough as the 3D printing technology. The last slide here, I'm just going to mention a little bit about our future plans. We're currently working on what we'd like to call the factory of the future, where we are planning to install multiple robotic arm units to create various processes of the housing projects. For example, 3D concrete printing is one of them. We will also able to do CNC finishing to produce smoother finishes of the wall. We'll also able to implement the robotics to insert the insulation into the walls, and also check for the MAP integration. And at the same time, we're working on creating mobile print factories where you're able to ship a 40-foot container to various job sites and print directly on site. So thanks again, Zigurat, for inviting me. And this was just a small glimpse at what we are doing. And I hope that you found it useful.
Amazing, Luay. Beautiful presentation and beautiful how you can design beautiful forms for our new houses. No? So thank you very much to bring these cases for our attention.
Sure, very welcome.
Great. So now we'll have a roundtable discussion with all the speakers, and I would like to invite a special guest for our discussion table, Rania Abdel Fattah. Thank you very much, Rania, for joining us at this wonderful event. So Rania was some time ago an alumni from the Master in BIM Management. Nowadays, she is mentor from our master. She's been director in Cosmo Eng and also a PhD candidate. So Rania, welcome to this discussion table. And what do you think about the presentations? Really nice, no?
Yes. Good afternoon, everyone. I would like to thank Zigurat for inviting me to Construction Week 2022. Thank you. Thank you, Rodrigo. Initially, let me start first by introducing myself. My name is Rania Abdel Fattah. I'm a BIM director with 16 years of experience. Believe me, I'm not that young. I'm a mentor of Master in Global BIM Management in Zigurat. Eventually, I'm also an academic director of the BIM training programs for undergraduate and postgraduate engineer in Egypt. It's my pleasure and honor to be with you today. I would like to thank Inj Mohammed Fawzi for the amazing case study on applied BIM in a real life mega project here in Egypt. Also, I would like to thank Inj Luay for his case study regarding 3D concrete printing. It was professional and valuable information. Thank you. Well, let's start our panel discussion today. The first question is for Inj Mohammed Fawzi. I would like to ask you, what are the impacts of using BIM in mega projects? We always hear about the benefits of BIM, such as it speeds up tasks, improve quality, reduce costs. So I want to know the answer regarding your experience managing the mega project using BIM technology.
Okay, thank you, Engineer Rania.
Thank you.
As you said, most of us know about the benefits of using BIM technology for the construction project. Mainly, I believe that the benefits of using BIM technology or any innovative technology is to help the site construction, even from the design stage. So if you make the design correct, if you fix all the mistakes or all errors that can be done starting from the design stage. So when you start construction inside, their job should be easier. Their job should be more accurate because the design is correct with a minimum number of errors or mistakes. So especially in mega projects, as you know, it's become a critical project. The time frame is more accurate, should be accurate, should not extend. and even for sure to make a mistake in a mega project costs much than to make it in a small or in an ordinary project. So to make sure that your design is accurate and to make the construction easy and to follow the time schedule is mainly one of the benefits, the most important benefit from using BIM technology in projects.
Yes. Yes. Thank you,
Thank you.
Muhammad. Yes. The magic word here is digital fabrication. My second question is for Ingeloy. I would like to ask you about the challenges you faced on applied 3D concrete printing in construction, and what are the proposed solutions?
Thanks, Rania, for the question. Well, there's a lot of challenges actually that we faced during multiple projects that we've worked on with this technology. Mainly because it's a really new technology that we haven't used before in construction, and we try to understand how it performs structurally and how it can be applied in adjacent to conventional construction methods. Because we're at the end of the day we're 3D printing the walls mainly, but we still need to use traditional construction methods to finish our project. So that was one of the challenges, is to try to understand how everything works together. But on the other hand, one of the biggest challenges was trying to get approvals for these projects from different bodies, governmental bodies, where we can prove that this technology has been tested and it works according to specific standards and regulations, and that we are able to use it into our projects to produce close to conventional construction projects.
Yes, thank you for your answer. Yes, I'm totally agree with you. So the
Rania,
same for yes.
if you allow me, there is some question that is maybe related
Yes,
with this
sure.
one.
Yes.
Some question from the audience.
Yes.
Marta Cos is asking for which climate it can be applied. I assume that this question is for you, Luai. This is the first question, and then we have another question that's for what seismic tremors is the house design? Interesting questions.
Yeah, well, very good questions. Thanks, Rodrigo, for mentioning them. The beauty about 3D concrete printing, it can be applied to any climate and condition. So we have projects that have been printed in Dubai and Abu Dhabi, the ones that I've personally worked on. So that's the extreme kind of hot environment, I would say, because in Dubai and Abu Dhabi, it can reach around 45 degrees Celsius in summer. So we have been able to prove that we are able to print in such conditions. And on the other hand, there has been projects already finished and completed in Germany, where the degrees can reach below 0 degrees. So it kind of fits in any conditions, and the case studies have been there. In terms of the seismic tremors, we have designed this building for the UAE, where we don't have a lot of seismic activities. And the ones that have been printed in Germany, I think, also relatively low. So we design, according to the standards and regulations we are working with on regular construction projects. So we treat it as a normal construction project, and that's why we take our calculations based on that. So really, in terms of calculating for seismic, we are basically working using traditional codes and regulations.
Great, thank you very much.
There is any question here? Oh, okay. So the same question is for Inge Muhammad Fawzi about challenges faced on applied BIM in mega projects and what are the proposed solutions.
I believe that the challenges for applying BIM not only in mega projects, even in any project, small project, is the lack of knowledge. Starting from the lack of knowledge from what is BIM and why shall we apply BIM and what is the benefit that we shall get from applying BIM. This is starting from the management, the owner of any company that we should give them answers to these questions so they can convince it with using this new technology. Once they are convinced and once they give their approval to start implementing them in their project, we are going to go to the next challenge, which is the lack of knowledge for their team. So their team should be well trained. They should be ready to use the BIM technology in order to succeed in using the BIM. So even if BIM or any technology is a good technology or a good tool, but the user should learn it first correctly in order to be able to give the correct output. So mainly some of the teams, technical teams, are afraid of change because they don't know if they are going to learn or to use the BIM technology correctly or not. So again, I believe that lack of knowledge is the main challenge because this is what decides if we are going to use them or not, and this is what decide if using them correctly can let us achieve what we need or not. So well trained is the most important thing in the BIM implementation process, so we can get the benefits of the BIM in mega project or even in a small project.
Yes, thank you, Muhammad.
Thank you.
So, 3D printing is a new technology here in our marketing in Middle East. So, I wanted to ask you, Angelai, what are the impact of using 3D printing here in our marketing in the construction phase or the
Yeah, I mean, the construction industry in general has been the slowest to adapt to the latest technology advancements in industries, various industries around the world. And the impact of having this new technology introduced in the markets is that we will be able to have an error-free kind of workflow where we are able to have a digital twin connection between our digital models and the actual printed models, because what we are printing basically out of the 3D model. So we're not really going into the drawings and from one person to the second, and the miscommunication that can happen and produce some mistakes on the actual construction side. So we will be able to eliminate all of the errors. We will be able also to accelerate our construction projects because the lead time is very slow, because also we don't need to produce molds for the printed items. And typically molds can, especially in complex projects, can take many months to produce before you actually start casting the concrete. So we don't have that with 3D printing. We're able to start printing it directly. So we will see an acceleration in the construction projects and a reduced time. And also it will become more efficient, and we will also be able to see new and innovative kind of designs that we were not be able to see before.
Yes, thank you. Yes, you totally agree with you. My last question is mainly for
We have another.
yes, Rodrigo. Yes. Go on. We lose Rodrigo. So turn back to my question is mainly for Zigurat students or beginner in the BIM field. So I would like to ask you, what advice can you give to beginner in this field? Yes, it's for both of you, Muhammad and Ulay.
Okay, you can start.
Yes.
Sure. Well, I've worked myself in BIM for many years in the construction projects that I was involved in, and my best advice is get your hands dirty and get learning the BIM and start utilizing it in your projects at university and so on. this is basically the future of how we design. It is not the future; it's the present. Actually, this is how the majority of and the most complex construction projects are being designed for construction. So if you're not being able to be part of or understand how it works and work with these tools, you will not be able to catch up with the industry. So try to learn it as much as you can, and basically this is going to be your future.
Yes, thank you. Yes, you said exactly what I wanted to say, and now I just wanted to hear Ij Muhammad. What advice can you give to a beginner?
It's the same. I agree with what Engineer UI said. My advice for everyone: don't panic. Don't be afraid from learning a new technology. Don't get panic from start of a new technology to be applied. Don't get depressed from the learning curve because each new technology, each system have a learning curve that you are going to start from the beginning and then you can go more and more. So get well trained for whatever you need, and then you can apply this system correctly. So the advice is study well what you need to apply or to use so you can successfully use it at the end.
Yes, thank you, Ij Muhammad. Rodrigo, you have another question, please.
Yes, I have a question, and it's a question for Angie Mohammed and for you, Rania, that you are working on the BIM environment. No, do you have a measure and how much is the impact that BIM can affect in a project? No, for example, in a mega project. No, what is the difference if you work with BIM and if you work without BIM? No, do you have this measure? How much the company can and save in cost, in materials? What is your impression and what do you think about it?
Yes, for me, because I have here many projects using BIM, we usually use SWOT analysis. That makes us feel like decided before and after what is the exactly impact in using BIM in our project. So it's a lot of benefit. It's only not about the mega project, but all the projects. That's because we here our project industry, so it's so complicated to be fully coordinated and our collaboration in this project. So I don't believe that we can do it without BIM. So it's so important for us here in our company. Yes.
Yeah, as the engineer Rania said, uh, besides the numbers or the percentage, but what we can save in using BIM for the project is starting from the time frame of the project itself that can be decreased and also beside the perfection of installation so you can install correctly from the first time. This is what any construction company need at their site. So I can install my building and my system correctly from the first time because this save time and save cost for this company and for sure for the whole project parties. So implementing them, and this is applied in some of the projects, save what we need from time and money, and increase the accuracy for sure and the quality of the project.
Great, thank you very much. I don't know, Rania, if you have any another question to Engineer Luay and Mohammed.
No, I don't have.
We are done. So thank you for all the audience to be here with us. Thank you, Mohammed. It was a great presentation. Thank you to you also, Luay, to bring to us this success case. And thank you, Rena, for leading this discussion panel. It was really interesting.
Thank
So
you.
thank you to be here with us. Tomorrow we have the second day of the CONSTRUWEEK. Okay, it's going to be about the construction stage. Okay, so hope to see you tomorrow and have a good day. Bye bye.